after a long research process carried out by the engineer and physicist Gabriel Barceló, with the collaboration of other Spanish scientists, the treaty has been published in 2 volumes, New Paradigm in Physics. In this text, the behavior of bodies subject to accelerations is analyzed, especially accelerations by rotation, and new keys are proposed to better understand the mechanics of the universe and to reach a most reliable scientific cosmology. After determining axioms and principles, the treaty proposes theory of dynamic interactions for the movement of systems accelerated by rotation. The main dynamic hypothesis is that the field of resulting and anisotropic velocities generated by a couple non-coaxial dynamically couples with the field of translation speeds, generating a new field of speeds that determines the curved trajectory of the mobile that we observe. In addition, with that same logic, the author confirms the aporia, or contradiction, that he initially exposes, that in the universe there necessarily coincides the rotation and the simultaneous orbitation of the celestial bodies. The treaty has its own internet website, which can be consulted for more information. Next, we describe some of the proposals of possible greater interest of the treaty. Calculation of orbits. In the history of cosmology, 3 mathematical procedures have been developed for the calculation of the orbits of the planets: Newton's model, Einstein's in the general theory of relativity, and theory of dynamic interactions. Einstein already considered that the Newtonian model was conceptually erroneous, even though it mathematically provides approximations very close to reality, which have allowed acceptable calculations and the discovery of new planets. Einstein's method is mathematically very difficult to develop. The TDI is consistent with the Einstein model and with Kepler's laws. Besides, it is mathematically very simple, and although conceptually it is clearly differentiated from Newton's, it obtains similar results of calculations of orbits, besides allowing to explain another series of phenomena not justificable in the Newtonian model, as for example the dynamic balance of the universe, the celestial flat system, to the rings of the stars as Saturn. Through the model of dynamic interactions, one could justify how a body in rotation can initiate an elliptical, circular, or helicoidal trajectory without the existence of a central force. Harmony of the universe. These hypotheses we see suggest new keys to understand the dynamics in our environment and the harmony of universe, a universe composed not only by forces, but also by its moments. And when these act permanently on rotating rigid bodies, also with constant translation speed, the result is a close orbiting movement, creating a system that moves, but in dynamic equilibrium, iterative and stable, be it with 2, 3, or more bodies in play, with a tendency to multiple coplanar alignments, stars orbiting around the same major star, with other possible windows and doors that this innovative proposal opens. Relativity. The theory of dynamic interactions is fully consistent with the theory of relativity, but suggests that this raises doubt about a generalization of Einstein's principles of equivalence. We propose to extend the analysis of this theory with the new dynamic hypothesis. Paradoxes. Although we barely notice it, we live in a physical world where everything revolves, a physical world with intrinsic movement on axes of symmetry. If we briefly analyze the concept of rotation in the evolution of the theory of classical mechanics, we always observe a certain strangeness and possibly also confusion in dealing with this question. Nowadays, textbooks and treatises of mechanics have renounced the treatment of paradoxical, avoiding this adjective to refer to the bodies in rotation. In this new rational structure of knowledge proposed by Dr. Barceló, the paradoxical phenomenon, or outside the main structure, are not incorporated to it, not accepting concepts like the one called pair-gyroscopic, or to argument the use of fictitious forces, as is usual in classical mechanics. The theory of dynamic interactions establishes new conceptual criteria for a description of mechanics that allows understanding the behavior of nature in more generalized assumptions. For more complete documentation of the theory of dynamic interactions, visit these links.